This new research about byte models looks eerily similar to megabytes, which is another research project which I covered some months back. In traditional deep learning, the fundamental elements of the digital world, bytes which represent all types of data and operations in a binary format, are often ignored. Drawing inspiration from the success of predicting the next token in natural language processing, this paper presents bGPT. bGPT is a model that predicts the next byte to emulate the digital environment. bGPT achieves parity with specialized models and across different data types, such as text, sound, and visuals, and unlocks new avenues for forecasting, mimicking, and troubleshooting software or hardware issues. It has replicated the conversion of symbolic music data with remarkable precision, exhibiting a conversion error of just 0.0011 bits per byte from ABC notation to MIDI format. Moreover, bGPT shows outstanding ability to mimic CPU functions, attaining over 99.99 accuracy in performing various tasks. If you look at this diagram, in this bGPT framework simulates digital system through native binary data and integrates diverse data types into a single model, treating everything as a byte sequence from left to right. This approach simplifies integration and expands application possibilities. In another example, in this diagram, bGPT segments byte sequences. If you start from the top as output bytes, and then it can segments them into the patches. Also, it predicts next patch feature with a patch level decoder and reconstructs bytes within these patches using the feature with a byte level decoder. Now, by predicting the next byte, bGPT and similar models can directly learn from extensive binary data, efficiently mirroring the complex dynamic of the digital arena. Working with byte level at the working with the digital data at the byte level not only allows models to learn digital systems patterns but also offers a unified approach for incorporating various data types into a single framework. However, the high granularity of bytes results in long sequences, substantially raising computational costs. This issue is more pronounced in transformer based models due to quadratic self attention scaling, restricting their efficiency and scalability for handling binary data. To address these computational limitations in transformer based models with long byte sequence, this is where bGPT adapts this hierarchical transformer architecture and segments a sequence of bytes into a sequence of patches. There is a lot of other detail around this paper. For instance, byte models such as bGPT excel at understanding binary data and have proficiency in digital media file processing such as text, audio, and images, and simulating algorithms and hardware operations for in-depth software and digital system analysis. So this is where I believe the real use case of these bGPT could be, because the field of deep learning is steadily advancing in its proficiency in both the generation and classification of diverse forms of media, including all of these multimodals. These media files, typically stored and transmitted as byte sequence in electronic devices, enable bGPT to process such digital content for generative modeling and classification. bGPT trains in generative modeling for representation learning via next token prediction. It then uses features from the final patch level decoder layer, employing average pooling to derive global feature for classification. And in order to streamline this training process, they standardize audio and image dataset. So this bGPT is presented as a versatile simulator for the digital world, extending deep learning to binary data processing via next byte prediction. Their experiments have demonstrated that the effectiveness of bGPT in modeling digital media data which showcases modality agnostic knowledge transfer. And they have observed strong scalability of bGPT in modeling native binary data and even signs of emergent abilities. There are a lot of good things happening around it. For example, not only emergent abilities have been observed, but also bGPT performs comparably to specialized models across diverse datasets without modality specific designs, and excels in data conversion and CPU state modeling, demonstrating its potential for simulating various algorithms and hardware. Now, there is a lot of future research happening in this arena. One last point I would like to make it that this model doesn't use one token per byte, it uses one token per patch, where a patch is, for example, 10 bytes and a separate transformer for individual bytes within the patch, reused for every patch. It's a hierarchical transformer like megabyte, so 100k bytes in this would perform roughly like 10k tokens in Llama. So this could be called as a variant of megabyte. Anyway, that's it guys. I hope that you enjoyed it. I will drop the link to this paper in video's description. Let me know your thoughts. If you like the content, then please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps a lot. Thanks for watching.